you find that a really clearly defined problem doesn't need some new technology. You have the ability to solve that problem internally, and you can use heuristics or some other means to do it with your existing capabilities.
Welcome to the Startup Defense. My name is Callye Keen. Today I have Terry Miller. Now, Terry, you're an expert in AI and ML in Industry 4.0. So that's a fancy term for smart manufacturing for everyone. And the listeners know my background's in manufacturing. I am obsessed with actually building things. We got connected from a mutual friend who's been on the show. So Russ Waddell, let's talk manufacturing. Let's talk about why this is important, what interesting things are happening in the market, and more importantly, to kick this off, what are you passionate about right now?
Probably everyone's familiar with ChatGPT and sort of the commercial applications of generative AI. I think, as is the case with a lot of these technologies, there's a lot of hype and a lot of promises of what the art of the possible is. But I think in execution, it's much simpler than that. But I am bullish on generative in manufacturing specifically, any sort of industrial application where it can be an augment to service technicians or production supervisors. I think there are a lot of benefits. But yeah, I'm passionate about generative beyond the hype of the commercial implications. I think there are a lot of really practical utilitarian use cases for generative in industry, specifically manufacturing.
How do you feel about generative in CAM solutions? So computer-aided manufacturing, programming CNC machines.
Yeah, so I think we can even pull back further than that application, but sort of the broader programming field. I think as an augment, it's not going to replace programmers. And I think it not in the same way, it's not going to replace artists. I think that's a concern for a lot of folks. But I think as an augment for code debugging, for sort of rudimentary simulation package, or ways to test code snippets before trying them in production, I think there are a lot of benefits. Troubleshooting or problem solving with machines that are actually in production. I think generative has a huge potential impact in that respect. I know we used it, my team used more in an enterprise setting, but we were training models for an enterprise application, and we used in our ML Ops platform, we used generative AI. It was a new feature of the platform, but we used generative to debug our Python scripts, and it was a very powerful tool for that. Very powerful tool. Not a panacea, but a very powerful tool.
To give us some context, and just you can disclose what you can, but sure. Where have you implemented Industry 4.0 or ML AI applications in manufacturing in the past?
Yeah, this is a fun topic because I think it highlights a few things. So I got in this, I think, fairly early. I finished a graduate degree in this space, and I started in 2014 and finished in 2016. And sort of while I was doing the graduate degree, I was working full time, but I was working for a major automotive manufacturer. That wasn't my employer, but I covered them for my employer. Started just doing I started helping them design in traditional vision inspection systems, laser profile measurement systems, quality, traditional automation systems that helped with quality. Well, some of the engineers that I had close relationship with figured out that could write code and train algorithms. So we did a couple of what I call skunkworks projects where we just used, sort of on-prem data ingest technologies that I had available and did some projects. And one of them, I won't get into the hairy specifics, but one was testing motors to go into cars, obviously, to test for improperly seated or missing components in the motor by their acoustic signatures or their acoustic profiles. So they had test cells set up where they would test them, and Bob, who's been doing it for 40 years, would listen to see if it sounded like the motor should sound. But they had quality issues that were sort of embedded in the process because obviously that's not a foolproof method. So we did sort of proof of concept with just off-the-shelf microphones, but a little filter pre-processing, and then some algorithms to evaluate what does normal sound like and establish that as a baseline, and then catch if there are different acoustic signature profiles from what normal was, we could catch that algorithmically. We were able to do that. They wanted to get as specific as being able to tell what components were missing, and that would have been a much more involved project, and we never got around to that. So that was one that was really interesting and enjoyable. The other was, and we didn't get to execute this because it turns out robot OEMs don't necessarily want to turn over access to data that comes out of their arms. We wanted to evaluate the relationship between a 6-axis robot's path, so the yaw pitch roll, the path of the robot, and premature servo motor wear by axis or for all axes. I was able to do that on a test cell, but in production, it's much more challenging for a variety of reasons, but the main one being it's hard to get all of the OEMs to agree to turn over data that's captured in the ARM. Those were a couple of projects that I did. There are others more quality-based, but those were the neat asset-based or mechanical system-based projects that I worked on.
There's this big push in manufacturing, and it seems as long as I've been in manufacturing, there's this push to get people interested and get them into the industry. And defense kind of has the same issue, hey, let's get people in here. We want smart people in. We want to get people into this skilled trade or into this space. And it's difficult with manufacturing to find a machinist, to find a fabricator. And instead of going, hey, I'm going to skip college and I'm going to go into manufacturing, which by all means it's a good path to a good job, I think we have largely missed this other avenue, which is that manufacturing is becoming a engineering job, an IT job, a cybersecurity job. It's becoming a very high level, interesting technical trade. And so the types of projects that you're talking about this sound attractive to an engineer, to a programmer, to somebody that's interested in the sciences to come in and say, maybe I didn't really think about this space. I thought about, doing a tech startup of XYZ, but maybe I should go look at these opportunities that are in the defense industrial base or that are in the automotive, manufacturing space, because I can apply nth level talent. You can pretty much, it's a big white space, right? And it's a huge dollar space, but those sound like very interesting projects, right? They sound like something that I would want to do. I don't know. Tell me what you think. Is like the impact of doing something like that. It might seem minor, but when you're talking about working with a large scale automotive company, those small changes might have dramatic results, right?
I cannot agree with that point more. And I've seen both sides. I have a good network of folks that have, work in Silicon Valley and the VC community that's active in Silicon Valley. Here's the dirty secret. And I don't know why anyone would choose this. Really smart people. I do know why. Really smart people that graduate with technical degrees from the Stanfords, the MITs, the Caltechs, the places where their funnels into FANG and Tesla and the technology companies. The dirty secret for those people is outside of the really special engineers, a lot of those people spend a lot of their time doing just really rudimentary tasks like A/B testing bits of software and just things that are that I haven't done it. So this is an assumption on my part, but they have to be boring. I would assume that a person with really intricate technical skills that not a lot of folks have would want to solve these big problems, would want to work on fun things like robots, industrial robots in a manufacturing environment. So I would say I totally agree with you. I think the cachet and the pay of the big tech companies is what lures the brightest minds. But I think there's much more interesting work to be done in the automotive wing of the Southeast, the defense industrial base, a lot of our manufacturing and energy spaces. There are some really interesting projects to be had, problems to be solved that I think those folks, if they had the opportunity to see that, it would give them pause. Now, the other aspect of that is I don't think the pay is comparable to what they get to A/B tests, little bits of software in Silicon Valley. And I think that's a gap that has to be filled. But the work is definitely interesting. I have seen that. I have seen both sides of that. And I think your point is a good one.
Yeah, I would say that if somebody's thinking about creating a startup, the upside is there because the market value is there. But I definitely understand that, yeah, if you go work as a middling engineer at Facebook, you could be making $200,000 or $300,000 in San Francisco. Locally, here in the DC area, they're probably going to put you to work a little bit more to make that money. But if you were, say, an AI ML specialist in this area, some type of data analyst specialist, you could be making that money or a little bit more. So to make the leap into manufacturing has to look at this like, how do we create a startup? So I push back on a lot of the manufacturing industry leaders that are saying, hey, this is a good job and people should come in and see what's available here. I think it's our obligation to train people up, but also to create competitive jobs where we can hire and attract top talent. And there are a couple of venture-backed manufacturing companies that have applied mass intellect and even just recently, ones that arguably are just tech-enabled machine shops. They've attracted tens of millions or $100 million plus of investment. And I look at it as somebody who grew up in a machine shop. I'm like, that's just a machine shop. They have robots and they have talented engineers, but their plan is great. But really, I understand the premise is they're saying there's not enough people here on the ground level. I can't go out and hire 5 machinists. I can't hire 5 machinists this year unless I want to fly people in from across the country. But in this area, I could hire 3 or 4 data scientists. I could hire a roboticist if I wanted to. I could hire a roboticist more easily than I could a journeyman machinist. I see what they're doing.
So you bring up an interesting point. I think there's a distinction between a generalist data scientist and a machine learning engineer that can execute projects on industrial assets. And with the latter, Russ and I talk about this a lot on our show. There are only, I think in the US, there are, and of course, a lot of these we've brought in from abroad, but there are only 22,000 PhDs in machine learning or AI in the US. And I think globally, the number is not much higher than that, like 26,000, maybe higher, 30-some thousand. Last I looked, it's been a while. So the point is that the domain there, and really that's the choke point. That's the bottleneck for scaling AI solutions in industrial applications, presumably the defense space as well. Is there just aren't enough people that know how to do it. And I think data scientists can do linear regressions and train linear models and do things with cleaner data sets, but industrial data is really, really, really hard to wrangle. You have considerations of the sampling frequency of the controller. And if it's every 100 milliseconds, you're getting a reading every 100 milliseconds. The cost of storing data at 100 millisecond resolution is astronomical. So how do you, the data ingest part, how do you have to write some compression logic and you have to do things. You really have to know the space to take into account the nature of industrial data. And the second point about that is industrial data is very nonlinear. If I'm training an algorithm on who's most likely to buy widget X in an enterprise, that's pretty standard dynamic or static data. It doesn't change a whole lot. But in an industrial setting, and I've seen this firsthand, you can have machines side by side on a production floor and installed the same, made by the same vendor, the same integrator, and they behave differently. And it's just voodoo. You could have different air feed to the machine and the filter in one line's different. The installation portion could be different on one of the two machines. There are a number of things that could make the two machines behave differently. And you have to be able to capture that in data. You have to be able to capture that to get models that make sense. And it's a real challenge.
It's definitely an interesting problem space to pursue. And kind of to fold the conversation back on itself, where do you see generative AI then supplementing some of those challenges and making use of the data? So going from that data acquisition to data intelligence, where do you see that playing in the ecosystem?
I see two spaces, and both to me, I'm really, really interested in. And how I go about getting involved is still a little murky. But so one is an Augment for technicians. So you have the typical production environment that I've been in manufacturing. You have hundreds of vendors. If you're taking into account servo motors and robots and cylinders and, power supplies. There are hundreds of vendors. The maintenance staff is not going to be expert in all those vendors. You can train a generative model on all of the vendors and assets that are in the production environment and really create sort of a technician assistant that would presumably reduce downtime, improve productivity, and potentially even mitigate some of the shortages that I know a lot of these folks have in maintenance staff. It's hard to find quality people, and a lot of them are retiring out. That's another problem. And I think a generative model would be a real augment in a complex production environment to boost productivity with the maintenance staff. That's one. The other, and we talked about it earlier, the other is, and I'll take the automotive manufacturer that I worked for. They had a proprietary PLC that they use for all of their global locations. And it's a repurposed brand that everybody knows, but it's specific for this manufacturer. Well, the number of people that are really good with programming that PLC, they're hard to come by. It's not a common brand. It's unique to that company. So as a programming augment, and it's not limited to that PLC, it could be any asset that's in the production environment. As a programming augment, how do we get a new program, a new line in with more efficiency, up quicker? I have to be careful here because giving away all the secrets, but there's also probably a path forward to take faults from assets and feed those into a trained generative model and get sort of a work order protocol based on what the faults are. So there are, again, for anybody that might hear this, or for just manufacturing generally, the use of AI is best viewed as an augment. It's not replacing anything right now. It's not sophisticated enough. And that's where the hype has to be. We need folks that understand that distinction between the hype and what's executable. But AI as an augment is incredibly powerful. And to boost productivity with existing staff, reduce downtime, reduce the consumption of raw materials, things that are big cost drivers in the production environment, AI can really help with that.
We have a piece of equipment and it has a very simple ML feature. It just listens to the cut. And so it's pretty intuitive. If there's supposed to be a tool cutting and there's no sound, it's probably a broken tool. Some very simple things, but more what it does, it reduces chatter, right? Moving RPMs up and down so you get better tool finishes. But that's a fairly simple application, but also it has a fairly trainable data set, whereas a lot of the pie in the sky, blue sky thinking that people have for manufacturing, and they walk through, this is what the new BMW plant is going to use Omniverse for a complete digital twin, and all of these things are connected. That is fantastic. But I work in the defense industrial base, and the vast majority of machined parts and all parts that are for the defense industrial base are produced by very small companies. Generally, they're owner-operated companies with under 30 employees. So there's thousands and thousands of these that are run by somebody who was a machinist, they started their own machine shop. Somebody who's a fabricator, they started their contract manufacturer. So there's thousands of these companies. And so they handle the low volume, high complexity work that makes the defense industry actually go, right? There might only be 50 of a part ever, or there might be 50 and then 2 every year for 10 years. And that's pretty common in the space. Of course, there's volumes that are higher, but making thousands of something is considered fairly high volume in manufacturing, whereas in automotive, that would be a pilot, right? That would be like a test quantity. When you take these blue sky, I bet it could program any part. It could show me exactly how to set this up. It could show me the right fixturing or how to design an end effector for this part, right off the bat. It's an anything to anything to anything, like multiple difficult problem, because the parts are variegated, the machines are variegated, all of those businesses kind of operate their own way. There's no unified way that they operate. And all of the inputs are from external companies, which they have different ways of designing parts, creating packages, creating models. So it's very interesting that you're taking this, and I don't know if you can see my sign behind me, but my sign says End Hype. End Hype was my old podcast. I am a technologist. I love new tech and I like to track kind of where it goes. But I think years ago, we went to IMTS and one of the larger vendors, they were showing off voice control for their mill. I thought, man, that's the craziest, most useless thing I've ever heard. It was cool. I mean, it's cool to, shout at your machine and get it to do something. But what scenario is this going to help me? On the other hand, I want digital twin to work, right? We've had Tim Shinbara on, right, from AMT. We've had Beast Code on, who does digital twin for destroyers and jets and for military equipment. And I'm very interested in this space because I like the idea of having a digital connected world and be able to pull sensor data and usage data off of it and train people and, 3D print replacement parts. But in practice, the defense industry has been really difficult because they're these bespoke systems or very low volume systems, and the problems are variegated. It's just like everything's a $1 or $1 billion system that there might be 200 of. So there's only 5 people or 10 people that know how to work on something. I see the progress. So I'm really bullish on it as well, but I'm really anti-hype about Industry 4.0, about AI in general.
What you describe is exactly correct. And it has its parallel counterpart problem with the ability. Here is sort of these are the guardrails for technology, including AI, for industrial systems. That's an umbrella term. Most of the applications themselves, so the production, as you explained it, especially for defense, you have unique applications that aren't necessarily scalable from an application standpoint. And then you have the compounding problem that there are very few people who know how to scale or execute the technology part of that. And it's not like Siri where you can train it and they still have to retrain that algorithm. That's the big misconception. That's not like you build that once and send it out into the wild. That's continuously retrained. It's why you agree in terms of service when you sign up with your iPhone, you agree to send them data because they want to retrain those algorithms. That doesn't apply in industrial settings because there's not one model that's going to work for even 5% of applications. There are too many distinct applications and not enough people that know how to do the bespoke solution. So I would say this, you'll find examples where company X has really realized the benefit of technology X, whatever that may be. But they've invested in a team or a person, or they've spent the money to bring in the resources that know how to uniquely engineer that solution for their environment. And they can't then go scale what they've done to some number of manufacturing sites or plants around the world, just because you have to replicate that model every single time. And I think that's what industrial companies trying to sell platforms like some of the ones I've worked for, that's the problem that they've run into, is the consultancies have told them you need to build this platform and you can scale it to all your customer base, but they left out that somebody has to engineer this every time. And that's the challenge that they all run into.
On a really positive, hey, let's move forward perspective, let's ride the hype a little bit. So people are interested in AI, they're interested in ML. And so when somebody, I talk to a startup and they're like, hey, we're trying to pursue this, I do steer them towards manufacturing applications and defense applications because I feel like there's just way more white space there. There's less people competing and the value of an actual solution is much higher. So if they're trying to start a new company or they're trying to look at like what's a knowledge space I could explore, hey, come over, look at this thing. Let's talk about what's happening in this sector. Let's talk about what's happening in this sector. But there's such a high barrier to entry because unless you're in the industry, there's really not like it's not as immediately intuitive or accessible. But what are some ways that people can explore this concept? Because we have general technologists listening to this, innovative people. What's a way that they can kind of get involved, dip their toes in the water and be like, maybe this is something I should pursue?
I would say, and this is the way I start all my projects. So I've found, and it doesn't matter where I've worked, that if someone's coming to me, they want to see what AI can do for their thing, their application. The first thing that I do is have them quantify what metric is this problem. What is it now? So if you're currently consuming, X kilowatt hours of power per year and you want to reduce that by 3%. So that's the problem, or that's the outcome that they want to achieve. Well, what problems need to be solved to deliver that outcome? And then you work backwards, but to attaching technical solutions to those problems. So I would say the best way and I think this is a non-negotiable, I think the best way for someone to dip their toe in the water is to really hone in on what outcome they want to achieve. What are the big strategic pillars of the enterprise? Is it reduced energy consumption? Is it improved quality, productivity? What are the big strategic pillars that they feel would impact growth of the organization or are strategic for the organization in one way or another? And then what problems need to be solved to deliver that outcome? And so if reduced energy consumption is the quantifiable outcome that they want, well, what are the problems leading to why can't you just use less energy today? And what would need to be solved? And then have a really clearly defined problem for someone to work on. And then hopefully you can find smart people that can attach a technical solution to that clearly defined problem. I've found, given all the constraints that we've talked about previously, I found that the biggest hurdle to get over is a clearly defined problem to solve. Most of the technology discussions are fishing expeditions and things that folks have seen work in some other environment. And would that work for us? Well, what is your problem? And I think a real clear problem to be solved lends itself more readily to a technology solution.
Yeah, I love that approach. It's very pragmatic. And when we run accelerators, we see generally the problem that people have is they haven't identified an actual customer, and then they haven't figured out what problems that the customer actually has. So that when we look at what it takes to raise capital, I just look at those two things and we have some very simple actions that they need to take. And if they don't do those, it's kind of like, why even bother with tech scouting and IP this and looking at grants and partnerships? If you can't figure out what you're actually trying to solve, why are we doing all this other work that's kind of irrelevant?
What's interesting too, Callye, is if that exercise is undertaken properly, if that exercise of what are the big strategic goals of the organization, what are the objectival sort of metric-based outcomes that we're trying to achieve, and then clearly defining what problems need to be solved to deliver those outcomes, in some non-trivial percent of cases, you find that a really clearly defined problem doesn't need some new technology. You have the ability to solve that problem internally, and you can use heuristics or some other means to do it with your existing capabilities. Not all. I think a lot of times it's just getting that clarity piece right really defines what, if any, technological solution you need, and you can have a much more targeted approach to solving problems that way.
Yeah, I'll pick on crypto because everyone's kind of sobered up from crypto. I have friends that had very large crypto projects. I have had people in different accelerators with crypto enabled this and that. And inevitably, when you pulled back the curtain of what they're actually trying to do, most of the time it wasn't something that even required blockchain as an approach. And that was the problem why I would say, hey, eventually, I don't think this is a good avenue, or you really don't need to promote this in your literature because the problem should speak for itself. And one unifying fundamental fact, and you can take this as a physics baked into reality part of life, is that people have problems and organizations are made out of people. So if you want a really great problem, you can go out and talk to people. You will find a problem worth solving, because if you solve those problems, there's just secondary and tertiary problems. There's downstream problems, upstream problems. There's always problems, right? Anytime you're trying to do something, there is a problem. And by talking to people, you can better define what the problem is. Very difficult to define what the solution is from somebody that's experiencing the problem, but people are really good at complaining, and they're really good at describing pain. Our brains are wired to remember pain, right? And so, yeah, usually when we go down this road, I think of it as like, can this be solved by a brick on a string.
Yeah.
Usually it can be solved very quickly, which is great for somebody getting started, whatever the tech equivalent of that very simple solution is, because you can start validating with customers. You can start actually building a business or learning the technology without having to make this ultra elaborate, cutting edge solution that you need to hire the people that get paid $300,000 or $400,000 a year, and you need the best BD and the best sales and the best marketing. In general, you don't, because if you're solving a real problem, it's like, yeah, how do we get 3% more efficient? Well, if I can demonstrate that, I can keep going down that road with a customer and, eventually build some amazing, cutting edge, mind blowing technology. But in general, I find a lot of the solutions are like, they really don't involve using technology the way that people want it to involve. I'm like, it sounds like you need a more sophisticated search, or maybe like AI driven tagging, but I don't think you need a LLM to do this. I think you just need to find the answers in your documentation faster.
The example of that is, one of the big applications that I've seen emerge from generative, and not big, but I've seen it emerge, is data querying with generative. Well, in an industrial setting, what could you do with a generative model that you couldn't do with Elastic? That's where AI and machine learning finds itself in a lot of instances, especially in industry. There are possibilities. The possibilities are very, very real for all of the things that AI and machine learning have been shown on a PowerPoint to be able to do. Those things are real. They're hard, and it requires real clarity to connect those things to problems that need to be solved that will make an impact on an outcome in an enterprise. And I think getting all those pieces together has been a big hurdle for a lot of the industrial base. I'll just say the industrial base generally.
Terry, this has been really great. I hope this jogs some people's desire to look at different spaces for different problems, including manufacturing, which is close to my heart. We don't often get to talk about it on the show, even though manufacturing is at the heart of what defense is about. Somebody has to make the thing that we invent, right? Somebody has to turn it into reality. So I appreciate you coming on the show and talking about manufacturing and talking about tech. So it was really good.
Yeah, thank you. Thank you for having me. I enjoyed it. Hopefully we cross paths again sometime.
My name is Callye Keen, and this has been the Startup Defense.